Hello and welcome to this video for Comp 6259, that's Advanced Games Design at the University of Southampton. My name is David Millard, I'm one of the lecturers on the course. In this first video we're going to be introducing the concept of procedural content generation, exactly what it is and why you would do it. So procedural content generation, or PCG, is essentially the idea that you're creating content for your game algorithmically by following a well-defined procedure. The key idea here is that it's not random. Right? PCG may have random elements, but it's not a random process. It is quite carefully managed because you want to make sure that the content you're producing is of sufficient quality and achieves certain goals within your game. If we think about PCG, it can fit into the development process in a number of places. So let's imagine we've got a developer, they're working with a game engine. The game engine generates the game code, if you like, that then is loaded by a player who then experiences it. Well, the first way that we might include content generation is at design time. So in other words, it's a tool that helps the developer produce things that they then load into the game engine and use within their game. And this is used really extensively in the games industry. It helps you have a lot of variety. It keeps you with quite a lot of creative control because effectively the developer can review all the things that are being created by the algorithm, and it's a relatively slow process. So that means that the algorithms that generate the content don't have to be working at runtime effectively. They can be fairly slow algorithms. The other place where we would typically place content generation would be at runtime. So that's between the game and the player. In other words, the game is running, and when the player runs that instance of the game, there is an algorithm that generates on the fly the content that they then experience. So this is useful for uniqueness. It means that every player gets a different experience, but you have limited control because you can't review as a developer what your algorithm is developing for every single player. It also means the algorithms have to be fast because they have to work at runtime. They have to work seamlessly while the player is playing. Now there's a little bit of a gap here, right? Because in theory we could potentially have content generation at build time. Now it's kind of hard to think what that would mean. It's very rarely seen. The only example I could think of would be something like Aaron Reed's novel, Subcutanean. So this is a print-on-demand book, and every time you order the book, it generates a unique instance of the book for you, which you can then which you then experience every time you read it. So if we had content generation at build time, that would mean that every single time we built the game, we would get a different version of the game. It's hard to imagine how that would work with our current distribution platforms, but it is theoretically possible. So why would we want to do procedural content generation? Well, the main reason is around the cost of producing content for games. If you want to have a large amount of content, if you want to have variety, then doing that all manually is very expensive. There's a second reason, which is that we may want to reduce space requirements. So all the content that we pre-generate, we have to package and deliver and store on the player's machine. But if we're generating on the fly, we only need to generate what we need as we need it. So there's a smaller amount of space needed. There are clearly drawbacks, right? So for a start, it's a completely different type of expertise. The sort of skill set you need to produce an algorithm that works effectively is very different than the skill set you need to, for example, design a level yourself or design a particular model. And it's also quite hard to get right. So particularly the runtime version, getting something that is well balanced and has the right level of difficulty, and we'll talk about that later, is quite tricky to do. And of course there is a loss of creative control because you're not reviewing what the player is seeing, so that can be an issue. Just in terms of the space requirements, if you think about where we saw procedural content generation in the past, it was used extensively in games like Elite, so that was in 1985. So Elite was trying to run on machines with very limited memory, and typically that would be something like 32 kilobytes. And it had 8 galaxies that you were exploring, and if you work out the calculation, that's around 12,000 planets. Well, if you can imagine, if you're trying to store basic data about 12,000 planets in 32 kilobytes, that's going to be almost impossible. So for a game like Elite, you had to use procedural content generation. It was required. Now you may think that that requirement has gone away, but if we consider a more modern example, something like No Man's Sky, released in 2016, well, that had 255 galaxies and 14 quadrillion systems. So if you work that out, it's actually something like 18 quintillion different planets and moons and organizational structures that the game had to store. So even though you've got 16 gigabytes, it would still be completely impossible to pre-generate that and store it all. Actually, generating it on the fly as it's discovered by the player is pretty much the only way to go. So, going back to the question of what, there's a really nice paper by Hendricks back in 2012 that talked about the different places that procedural content generation can occur in a game. And essentially it forms a pyramid with game bits at the bottom, so that's kind of like the assets that you would use in the game, things like textures and sound and buildings, those kinds of things. Then moving up, we have game spaces, so indoor and outdoor maps, for example. Then we have game systems. That might be things like ecosystems or road networks or the behavior of different things within the game. And then we're starting to get into higher level systems, so things like game scenarios. So that might be different levels, it might be story beats or dramatic moments, it might be particular puzzles. And then we can actually imagine something which is generating the game design itself. So that might be the systems design, the actual mechanics of the game and world design. And at the top we might have derived content, so that's kind of secondary materials about the game. So that's kind of like news about what's going on in the game, leaderboards describing what's happening in the game, essentially things that communicate meta information about the game to the player. Now in this course we're going to mainly focus on things like vegetation and buildings and the game bits level. We're going to be looking at game spaces, looking at indoor and outdoor maps, and we're going to be having a look at game scenarios, in particular looking at levels. And then in future weeks we're also going to have a look at some of these higher level things, in particular how you might do dynamic generation of stories and worlds, and also how you might look at news and broadcast and how you would report on things that are going on in a game. Thanks very much for listening, and I will see you in the next video.